Hello, hello. Is this better or not really? Hopefully my microphone should be a bit better right now. I shouldn't be lagging that much either. It should be perfect, but it's good. Awesome. Great. Okay, so as I was saying before, um, in a TCP protocol, it basically the idea is to guarantee that the messages are delivered and received, um, make it a reliable way of communicating. There are other protocols as well. So you have UDP, which doesn't do that. Um, but the trade off is that there's less overhead, um, and it's suitable for different things. You want a reliable connection between a server and a client where you want to make sure that messages are delivered and in a specific order, then we should use TCP. Um, and that's what we're going to be doing. So first we create a socket object, and this is our socket object. Now what we want to do from the server side is we need to bind it into a host and a port. We're basically saying, basically telling the socket that you're going to be working with a particular IP address with a particular port. In this case, since this is the server, we're going to be using our own IP address. So let's make a tuple. So host and port. The tuple is going to be home because this is the IP I wanted to listen on. And the port can be whatever you want to listen on. In this case, I'm just going to put 8080. Now to bind this, we just do s.bind. And in here, if you see this little tooltip, it accepts a tuple. So you don't put the host in the port, you put a tuple with the host in the port. So this can be tricky sometimes. You accidentally just pass the host and port except without it being a tuple. So now the socket is associated with our IP address and with a particular port. Now we need to listen for connections. To do that, really easy, s.listen. Now in here you can specify a number of connections, unaccepted connections that are allowed at the same time. Well, before closing it, before refusing more connections. This will be useful later on when we want to accept many connections and whatnot. But for now, we're just going to leave it default. By default, it has a default number. I think it's OS dependent. I'm not quite sure what number that is exactly. If you want, you can just put 1 for now, since we're just going to be listening on one connection. And we're almost there. The only thing we need now is to actually accept a particular connection. So all this does is it sets, it first binds the socket to the IP and port that it's going to work with, and then it sets its mode into listening mode. So it's basically a server socket. Now we need to actually accept a connection or wait for a connection. To do that, we use s.accept. Now, if you look into this, it returns a tuple. What this actually returns is, well, it is a tuple. It's a tuple that contains two things. So it's going to contain socket object, and it's going to contain the address of the remote connection. So what I'm going to do is I'm going to do connection and addr for address equals socket.accept. So now the tuple that it returns into is going to go into connection and address. And this connection is going to be another socket object because it's returned by this. It's the return value, right? It's the first element of the tuple returned. And this connection object is the one you're going to be using to send and receive data. Okay. And this might seem a bit confusing, but it will make sense in a bit. From the client side, it's really easy as well. So let's import socket. We need a host and a port. So let's just copy up into here. In this case, it's the same, but if you're using different computers or the different networks, you're going to have a different value, a different IP address you want to connect to. So this is where you want to connect to. The port has to be the same, of course, because if it's listening on this port, it expects a connection on this port, so you have to connect to that port. And we also need a socket object, and it's going to be the exact same because, of course, we're doing the same kind of connection. But now all we need to do is we need to connect. And to do that, we do a socket s.connect. And we're going to connect to a host and a port. Again, tuple. Don't forget to make it a tuple. And now we're connected. If we run this so let's run this real quick. So I'm gonna be setting up two terminals, of course, because one is going to be I'm just activating my virtual environment. If you have one, you should. If you don't have to. One is going to be for running the server, of course, and the other one is going to be for running the client. Now, you notice that as I executed the server, it hasn't stopped, so it's waiting for a connection. When I execute the client, it does seem to connect, but then both of them just exit. And this is because we didn't actually do anything with this connection. To do something with this connection, we have to either, well, send or receive some kind of data, right? So to send data, we use this connection object. So connection.send. Let's send hello. And to receive data, we just use the socket object. In this case, it's not the con because there is no con, because this connection object just happens, by the way, because you have a socket object that is your server, but you need to communicate with the client. And this accept connection is what actually returns the object you're going to connect with. So this connection is your portal between the server and the client. So you use this connection. So we're sending hello, and here we need to receive it. To receive, it's really easy, s.receive. And here you can specify the number. You have to specify a number, the number of bytes you want to read up to. So if you put 2048, it will read up to these bytes. And we can actually print this out. There we go. And since we opened a socket connection, we can also close it. And we can, of course, also close it here if we want to, as soon as the program is done. Okay. Now we execute the server and the client, and we notice that the client received a hello and printed it out, and both of them just close. By the way, if you don't put this, it will close automatically. Just good practice. You can use a with statement as well. But yeah, so this is a very simple way to receive and send data. And this might seem a bit too much information for now, but it will be really easy once we start using it a lot. This way of creating the socket object is always going to be the same if you're using IPv4. And this is really the only thing you need to do. You need to do a couple more things if you want to accept multiple connections at the same time, and we'll handle that in a bit. So, any questions so far? Anything that I explained in a really confusing way you'd like better explanation for? Hey again, Spoiler, how are you doing? Oh, oops. This should not be there. It seems not. So let's continue. So how would we, for example, keep receiving everything that the server or the client sends? In this particular scenario, we're going to do a while true loop, right? And let's import time as well, so we can have a little delay, so it's not, And here what we're going to do is we're going to do a connection.send, and we're just going to send hello every 2 seconds. Okay. Now here, if I just receive this and print it, and if we run this, you'll notice the only thing that actually happens is the client receives hello once and exits. Right? This is still trying to send it because of the while true, but then there's an error because the connection was aborted. Of course, because our client ended, so there's no connection anymore. Okay. So what we have to do from the client side is you have to have a while loop again. You can have a while true loop, and where we're going to print whatever we receive from this connection. And now if we run this, you'll notice that we're going to be receiving hello every 2 seconds, and we're going to be printing it. There we go. Pretty easy. And we can cancel this out. Okay. So what would be the first thing that we want to do if we want to set up our ransomware server? So we want to build up on this to set up a ransomware server. And for now, there's only going to be one client, so we're just accepting one connection. We're going to look into threading in a bit. And by the way, there is something that I should also say. Let me do it real quick because it's actually pretty important. So let's say that we expect a particular order of things to be sent. So let's send, first of all, well, let's have a greeting, and our greeting will be, say, hello. Let's put it all caps. And then we have a body, let's say some message. So this is the body. And we're going to send both of these. So we're going to send greeting, and we're going to send body. You might expect, if you do things in this way, and on the server, if you receive it, so if you say greeting equals connection.receive 2048, and body equals connection.receive 2048. Since we're sending once, receiving once, sending twice, receiving twice, you might expect this to just print the greeting and the body correctly, right? But if you run this, oh, oops, what did I do wrong? Oh, this is not bytes, idiot. Okay. So let's do that again. There we go. So you'll notice that at first you have hello, this is body, and then you don't have anything else. So the greeting became everything and the body is nothing. Why did this happen? Well, because remember when we do the connection.receive, we have to put a number. So it reads up to this amount of bytes. So if you send 5 bytes, it will get put into this variable. But if you send anything more, if you send anything more up until these 2048 bytes, it will still get put into here because it's still receiving it up until that number. So a way to actually separate the different things that you want to send separately, what you can do is first, well, there are different ways to do this. You can set up, you can receive a specific amount of bytes. So let's say you want to receive 5, right? Now, if you do this, what it will do is it will, the server will first, so let's run it up. There we go. So now it prints the greetings, which was hello, and then the body. And this is correct. Because first it will try to receive 5 bytes, and we send hello, which is exactly 5 bytes. And then this ends and puts it into greeting. And then it tries to receive the next thing, and we put something else, which is the body, right? This is not an amazing way to do this, because what if you change the greeting size, or what if the body is big? So what we can do as well, is let's say, for example, that we have split signal. So let's say we have a split equals end, and then end which equals all. You'll see where this is going in a bit. And I sometimes do this because it's a bit easier it's a bit faster to do this. In the server, we're going to make it end all for a very particular reason that you'll see in a bit. Actually, let's just make it split plus all. And now what we can have is messages, and we can have a little tuple of messages where you can send hello. This is part of the body. This is another thing. So we have 3 different strings in here. Now, what we can do now is, so for message in messages, we can send it, the message, plus our split. And what this will do is it will append end to each of these messages. And at the end, we're going to also send the end. And you'll see exactly what this will do in a minute. On the server, of course, we need to interpret this. So our message is going to be, so the message is going to be the connection that receive. Let's just say 2048. And here is where it doesn't actually matter. So 2048 is perfectly fine. Now, while end not in message, so while we don't have our ending, we're going to keep adding the connection that receive. So what this will do is basically, oops, not in message. So essentially, until we mark the message as ending by saying end all, we keep receiving it and putting it on the same variable. So now if we print message, you'll notice that it's actually exactly what we tried to do, hopefully. So let's try it out. There we go. So this was the message. Hello, end. This is part of the body, end. This is another thing, and all, right? And the reason why here end is just all is because since I'm appending end to everything, this will also have end. So we only need to append all, not end all, right? So it just makes it a bit neat. And now this allows us to do something really nice. It allows us to just split it on our on what we want to split. So we can say, if we expect a greeting first, so we can say greeting and then a body equaling message dot split by split character. And I'm going to put another variable in here. Now we can print, let's use f strings so that we can do something like this. And try this again. Oops, oh, sorry, my bad. I'll explain this in a second. Just want you to see it working. There we go. Now we have our greeting, which is hello, our body, which is this is part of the body, this is another thing, and we don't have anything else because that's all we printed. Now, let me just show you what happens if I do message.split here. So if we just print this out, the message.split, this would be it, by the way. So it splits on everything that has our split, which is end. So it splits on everything that is end. So what this will do is you have a whole message, which will be, let's actually just print the message because it will be easier. Let's just do that. There we go. So this is the message that we end up with, of course. Let's just open up a quick notepad here so we can look at this. So this is the message that we get. Let's eliminate the bytes for now. So when we split on end, what we're actually doing is we're removing this, separating it, and removing this, separating it, and removing this, separating it. So you notice we get a couple of things. So we get first our greeting, and this of course gets put into an iterable. So let's just imagine this is a list. So this is what the message.split actually does, right? It returns this. Now, when we assign variables to this, so we're assigning greeting, body, and another variable. What this will try to do is it will try to fit everything inside of these variables. So it first starts with, well, hello, goes into the first variable, great. Then the next thing, which is this is part of the body, goes into body, great. Then the next thing goes into here, great. And then it takes all and there's nothing else to put it into, so it gives you an error. Awesome. When you do the asterisk, what you're actually doing is you're telling you're making body be able to hold an iterable. Let's think of it as that way. So if you just do this, so if I do, where is it? Oh, if I do this, by the way, what I'm actually doing is what is happening is the first thing is going to be put into greeting, like normal, and then it sees the asterisk. It sees the asterisk and says, well, everything else gets put into here, right? If there's more, like it's going to be an iterable of all of these things, and we can show this really easily by printing body, right? Let's just print body for now. And when we do this, there we go. We printed more things. Oh, because we printed the message split first. So, and this is body. And you see the body is an iterable. But here's the problem. Body has this last thing, which is all, for some reason. Well, it's because, again, it splits on end. So because the last thing ends in end all, it will contain the all as the last element. So you want to get rid of this all because you don't need it. One way to do this is to add another variable here. And this can be any name. We can name it blah. And if we do that, you'll notice that there's no all anymore. And the reason for that is because what it's actually doing now is the first thing gets into greeting, the last thing gets into blah, and everything in the middle gets into body, right? That's what you're actually doing. And that's what this asterisk is for. If you just have body, it's expecting this to only hold one element. Whereas when you put an asterisk, it can hold any number of elements up until this last one, because this is the first one, this is the middle, this is the last. Awesome. And the reason why I put an underscore instead of a different variable name is because we don't actually care about this all. And by convention, it makes no difference in the code, but by convention, we put underscores for variables that we don't care about. It's for future programmers or future people who look into this code, or you in the future will look at this code, and you can immediately tell that this variable you don't care about. So that's why I put an underscore there, because I only care about the greetings in the body. And in this way, you don't have to actually, if we do it like this with our splits, we don't actually have to, receive a particular amount for greeting and a particular amount of bytes for the body. We can just receive everything and then split it. And it's up to the client to separate these. This is a way you could do this. There are other ways in which you can do it as well. You can, for example, you can have a header. Let's say you have, in your server, you're always going to be expecting a header let's say the header has 16 of size, so you're always going to receive 16 as the header, and the header will always tell you how long the next message is, and then you can receive that message. So for example, let's make it so build header, actually no, just make a send message. We're going to have a socket, and we're going to have a message, and we're going to have Okay. Build header. So I guess we can have a build header as well. And the build header, we can have our actually, we don't need a build header. We need a padding. So if everything is going to have 16 in length, what we want to do first is create the header when we're sending a message. So the header is going to be equal to length of the message in string, for example. We can encode it as well. And we can add padding to this. And then our padding is going to receive our message, and it's going to receive our block size, which is going to be default to 16 because that's the header length. And our pad character, let's just say it equals to 0 in bytes. And this will make sense in a bit. Now let's say we want to left pad everything because we want it to be a number, right? So it's kind of like a little hack. So what we can do is we can just return, oh, actually we have to check the length of the message. So if length of message, well, actually we don't have to. So let's just return, so we have our block size minus our length of the message, modulo block size, and pad times this plus message. Okay, I should explain this. So let's go into the Python interpreter real quick to explain this. What is the idea of padding? So padding, let's say we have a string. So let's say message equals hello, right? Oops, equals hello. But we actually want to receive a constant size. So we always want, say, 16 in size of what we receive. We can use padding to add characters either to the left or the right to make that into a 16 size, right? And how would you do this? So, well, length of message is 5. So how do you add stuff into it to make it 16? Well, if you have our, let's say our block size equals 16, so that's what we want. Well, you can just subtract block size minus the length of the message, which is 11, because it's what's left for 16, and then add it to the left or to the right or whatever you want to do with it. So let's say I want to add a letter A that amount of time. So I can say A, so I can say new message equals A times this plus message, right? If we want to do it to the left, because we're going to have a whole string of A's, this amount of A's, and then we're going to concatenate with the message. Oops, something is wrong. What did I do wrong? Oh, I'm an idiot. There we go. And now our new message, see, it's this. And now if we have our length of new message, this should be exactly 16. Right? This is really easy. Now there's a problem with this, of course. What happens if your message is over 16, right? So let's say that our message now is hello, but with a bunch of O's. And this is 22, so it's over 16. So when we apply our new message equals this, it still remains the exact same. And that's because, well, the result of this now is actually negative. And if the result is negative, this is going to be empty, right? So if we do times 1, it's just going to be 1 times 2, 2 A's times 3, etc. Times 0, it's nothing. And as soon as you get into negatives, it's always going to be nothing. So it doesn't change. And we don't want that, of course. So one thing we can do is we can do the same thing, except here add a modulus block size. Oh, block size is not defined. This is the message. Oh God. Okay, let's just make this pretty. So our message is going to be hello. Let's print the length of the message. 20. Perfect. Our block size is going to be equal to 16. And our new message is going to be equal to, say, a times our block size minus the length of our message modulus block size plus message. 1, 1, 2. Oh, there we go. Now, if you look at this, if we look at the length of this message, this is 32, which is a multiple of 16. It's just twice 16. So what we're doing with the modulus is if the number is greater than our block size, what the modulus is going to do is give us a remainder, or if you would like to think about it in a different way, it's like circular counting. So thank you so much for the follow, Dantrol. It's basically going to be like circular counting. As it will basically, okay, think about it in this way. You have a string of 20, of length 20, and now you're going to divide this by 16, which gives us 1.25. But since 16 of those are already accounted for, you're just gonna work with the remainder, which is what the modulus is gonna do for you. And so you're only shifting the last portion of 16 characters, or you're only padding the last portion that needs it, because all of the other things that are already 16 in length are fixed. We don't actually want this. This might be useful if you were looking for a multiple of a particular number, but we don't actually want this because we want our header to be exactly 16. But we can still do it like this, or without this. If we do it without this, the result will be this. Well, it won't be the same, but for our purposes, it will. Maybe we want to change it at some point. I'm just going to leave it. Doesn't really matter for right now. But this is the header. Okay. Now, what we can also do actually, so let's say padded equals this. And now let's say if length of padded, padded equals 16, because that's what we want, or equals block size in this case, because we can change the block size, we're going to return true, and we're going to return our padded. In any other scenario, we're going to return false, and we're also returning our padded, because why not? Now we can do a status header equals this. It's the return address for this. And now if status, which means, so if it's true, it means it's correct. If it's not, it's false. So if status, now we're going to send this. So s.send our header. Perfect. We already encoded it. Great. And after sending the header, of course, we need to send the message, which we can encode as well, I guess. And that's it. And I guess we can also return true, and here we can return false if this doesn't happen correctly. Right? Perfect. Now what we can do is we can do a send message, and we can send whatever we want. Hello there. I even spelled it wrong. That's fine. We have to specify the S. This is the body. Still part of the body, but maybe another thing. Doesn't matter what we do here. Now in the server, of course, we have to interpret this in the server. So we're always receiving a header. Now, the message length, so let's say message size is going to be equal to an integer version of this header. Of course, we have to decode it first. And then our message is just the connection that receive of that message size, right? And we can print, we received this message. And now I'm just printing it so that you can see that we are able to separate data without needing, all the dirty splits and whatever. We can just separate it by including headers that we can just automate with a function, and then we can just send messages. So if we do this, so let's have a server and a client. Oops, something is wrong. What did I do wrong? Oh, I'm an idiot. Am I? Oh yes, because it's switched. Because here I send the message first and then the socket, and this was receiving the socket first and the message. But yeah, sorry about that. And something else. Oh, is it already? Oh, it's already encoded. Well, it's not encoded for, being easy, like, There we go. And there was another problem. Oh, of course, idiot. So let's actually do this in a different way, because here's the thing: when the connection stops, so you see that this was actually good. So we received this. So we received the hello there, which was our version of the greeting, and we can change the the size of this, and it's going to be the same. It's going to be received separately, and we're going to receive the body and this. But after this, it receives this, which is obviously not a valid number because it's interpreting it as the header. And the reason for this is because the connection was closed. And when the connection is closed, the client sends an empty string. And so to mitigate that, we can of course also do if, so header equals receive this. We can also do if header or if not header, just break out of the loop. But it's not really clean to me doing it in this way. I prefer doing it like this. So first you define a header being this, and then you make operations out of that header. And then we reset the header again. And this is the exact same thing as before, except now we can say while header. And if we do this, there we go. It will stop as soon as header is not empty. Sorry, it will stop as soon as header is empty. So there's no need to handle this anymore. And this is cleaner in my opinion. And we receive things separately. And of course, if you change the length of this, we'll still receive it separately in the same location, right? So this is a way to not have to use the splits and what. Wit. Yes, I am Portuguese. But yeah, so this is how you would you would separate messages. And that's really it for basics of communication with sockets. Now, what we actually want to do is communicate with our ransomware, our ransomware client. So let's figure out how to do that. So I was thinking first, so first I thought maybe the server should generate a key and send it to the client per request. But it might just be easier for the client to send a key back. To just send the key to the server and the server to log. So let's actually do something different. So now we have accepted the connection. The first thing we're going to do is we're going to have the auth exchange, which we're going to define. This is going to exchange keys. So we haven't touched a lot into about encryption just yet, but what we're gonna want to do in the end And we're going to talk more about this when we reach the encryption part, which we still have to tweak because our encryption is still pretty bad. But it works for now, so we can do everything, and then all we have to do is change in here in our module how it encrypts and decrypts, and everything can stay exactly the same, almost, perhaps. But we want to encrypt our traffic as well as communicating, right? Because if we're just communicating in plain text, like if someone is using a monitoring tool, monitor network traffic, and is able to capture those packets, they will be able to see in clear text exactly what is being transferred. And we don't really want that. We want to kind of encrypt the traffic. So one way to do this is to pass, so we have our server and a client, and as soon as the connection is established, a key is passed from one side to the other, and things are encrypted with that key. And then the server can decrypt it without anyone else being able to. So we're going to kind of mirror that, although it doesn't actually work in the intended way right now because we're not using RSA or any asymmetric encryption. We're using symmetric encryption. So it doesn't actually work in terms of security right now, but it works. But it will work later when we change the code to reflect that. So we also want, so from modules, we want to import crypto because we're going to be dealing with keys here. And we want a keychain in our server as well. So let's make our keychain as well. And this could be a database. It could be anything. It could be an SQLite. I'm going to just do like a JSON file for now to keep track of things. So how would I load our keychain? Well, we can load our keychain and save our keychain, I guess. And we're going to also be saving our keychain. And file name is just going to be default to, I guess, keychain. .json, I guess, right? And that's it. So we're going to do with open file name as as read. And we're going to use the JSON module. The way the JSON module works is you can do a JSON dot load. And what this will do is it accepts our oh, here, yeah, it's a load. Never mind. I just wanted to make sure it was load. It accepts a file object, so to load from. So let's say loading from F. We call this F. And we might want to just return this. Actually, do we? Yes, we do. Okay, great. Let's import OS as well, because what happens if there is no keychain, right? If there is no keychain, we'll create one. So if not os dot path that exists, file name, what we're going to be doing is with open file name w pass. We're going to clean this up a bit, but for now this should work. And to save, it's going to be the same thing. So it's going to be JSON, and we're going to have the same thing, except we're going to do .dump. Also, we need to accept a keychain. So JSON.dump, and first it accepts the object, so the keychain, and then accepts the file, so F. There we go. And this is as right. There we go. Great. So now we can load keychain and save a keychain. So the very first thing we're going to do is, right from the start, is have our keychain equals load keychain. Oops. Keychain. The default arguments. Do you know C? Yes. That is actually going to be our next step. So this is a programming fundamentals course. So we're starting with Python. After we're done with Python, we're going to go into C, and then we're going to go into assembly. And this will serve as the basis for reverse engineering course later on. And let's actually put the keychain first, because the keychain is our obviously our positional argument. Okay. So now we loaded the keychain. We have an object. And this object, actually this is stupid. I want to json.dump in F, and I want to dump, I want to dump this in F, okay? Because when it loads, I want it to be a valid JSON object so we can actually load, so we don't get an error if the file is empty. So it's going to be just an empty object when it loads if it does not exist. If it does, well, it returns whatever was in. Okay, great. So we are doing our socket things. We're accepting the connection. And now we want our auth exchange. And here's where we're going to save our keys. So connection ADDR is going to be passed into here, so we can handle with send and receive from these connections. And the very first thing we're going to do is we're going to receive well, we can receive, I want to receive like an identifier, something that identifies our client, so that we can use as a name as well. We can use the IP address, but if you have a lot of people that share the same IP address, you might not want to do that, because then, so something like the desktop name plus the IP address, something like that. So so again, first we're going to receive a header. So connection.receive 16, and you know what? Let's just put message size is going to be equal to int whatever we receive dot decode. It's just easier to. And then we're going to do our and we can automate this later on. It's just for us to see what's going on. And we're going to have our host name is going to be equal to, it's not necessarily the host name, but it's going to be equal to connection.receive the message size. Okay, and this has a limit. We haven't actually discussed it yet, but it shouldn't matter right now. And let's just print the host name for now. So we're just going to print the host name, and then at the end, we're just going to close the session. So in the client, what do we actually do? So right now we're not doing anything. So we have to get our own host name, which is done by socket.get hostname. And now we're going to send this host name, but this host name is in string, so we want to encode this. And let's try this out. See if there are any errors. There are bound to be some at some point. So go. Oh, there actually was, because yeah. Okay. Fair enough. So yeah. And that's because I didn't use this. I should have used this instead. We made a function specifically for handling the header stuff. So, oops. Oh, we don't even have to encode it, because we already took care of that. That's great. So server, client, there we go. And we got our host name, which is the name of our computer. Like it's the computer name in Windows. But this is not enough uh, because more than one person can have the same name, so we can. It's not enough to identify you. So we might want to also add in the address. And I didn't show you this before, but if we print the address, it's actually a tuple. And it's a tuple that contains the address and the local port being used. So we don't want the port right now, we just want the address. So we can say hostname.decode plus ADR0. This can be our user ID, right? And now we can print our user ID. And because this is a local connection, this will be 127.0.0.1, but this would be the IP of the victim. And we have our identifier, our string. Now what we can do is put this in our keychain. So let's say if well, let's receive a keychain as well, I guess. A keychain. So it's not very optimal, but we're gonna take care of that. I just want to show you the concept. So if user ID not keychain, keychain user ID is going to be I guess it's going to be an object, and we can also now generate a key for ourselves. So let's yeah, we imported crypto, so let's do a crypto dot key generator, because remember we already did all of the key generator thing, even if it's not a very good encryption right now. It's just a made up really basic encryption. Key length equals 30. Whatever, sure, why not? And this is our key, right? So we can also have our keychain user ID key equal to this key, and we can do a connection.send key. And if this is the only thing that we send, well, in our server, we can just receive it. So we're gonna in our client, sorry, we just receive it. So the send message. Now we have to receive our key. So our key is gonna be s.receive 1048, and then we can print our key just to see if this was correctly done. And at the end, we can also save our keychain, and we can load it up with our current version of the keychain. Now, if we look into our keychain.json, it's currently empty. So let's see if there were any errors in the coding of this. Oh, there were. Oh, byte array is not JSON serializable. That's fair enough. We cannot serialize byte data into JSON. I guess we can use base 64. Base 64 is just a way to encode. Aqui está dentro de pasta ransomware. This is inside folder named ransomware because we're building a ransomware. It's a project. We're building a ransomware project. It's part of our Python fundamentals course. Sorry, it's part of our programming fundamentals, and this is our first project, and we're building a ransomware. So that's why it's in the folder ransomware. I'm not sure I understand the question, but if this answered, base 64 is the common way to encode anything really into a byte string or into an easily convertible string that we can just work with easier. It's not a secure encryption or encoding by any sense. It's just a way to easily convert bytes into a string. I want to say it like so we can use this. So we can say that key equals base64.base.b64 encode. I believe this is the correct method. And we can now send the key. And now let's actually delete keychain.json so we always have like a new one. So our server, our client, and there's another problem. What is the problem? Oh, of course, because we have to decode this, because base64 encode returns a byte object, so we have to decode it, but this is easily decodable into a string, so that's why nice to have. Let's delete our JSON file because it got a bit corrupted there. And there's another problem. Oh, because we're sending a string. Yeah, I'm an idiot. So how about we send the key and we put in key.decode. This is better. There we go. Sorry, like coding live, always some errors. There we go. And we finished our communication between the server and the client. And if you look at our keychain.json, we have our ID, which is our desktop name, and our IP. So it's kind of unique-ish. And then we have our key, which is this. And if we decrypt this, by the way, so let's, and here we printed our key here in our client, but we can very well, and this is where base64 comes in handy. Instead of printing the key, we can print base64.decode base64 decode key, and this can be bytes or string. It doesn't really matter. Oops, did I do something wrong? Oh, because yeah, it didn't actually send anything because the user ID was in the key. So you know what? What I'm gonna do is I'm going to not save the keychain. Instead, I'm going to print the keychain. In this way, our keychain always stays empty, so we don't have to keep deleting it. There we go. So this is the keychain. And when we decode the key in our client, we notice that this is actually a byte array, and it's the key that was generated. If you want to make sure that it was the key that was generated, we can always just do I'm just going to do like f key equals this just for now, so we can print the end. And now you can see that the byte array is this that we just printed, that we just used. And if you look at the base64 decoded version, it should be the same. And yeah, it's exactly the same. Perfect. So this is working. We don't have to print these anymore. So now it received a key. So now we have to base64 decode it, right? So we can just do base64 decode. Base64 decode this, right? See? And now we can start encrypting all the files. So remember, we also need from module import crypto and splash, because we need to show the splash screen. So here we're going to do a crypto.encrypt directory. Let's encrypt directory named test, because that's how we're testing it right now, with the following key. Okay, perfect. There we go. Great. Now, oh, and now we of course need to do a splash.display hacked, and our address. Let's just put a BTC address for now. It's just going to be random BTC address. We're not going to put a number right now. There we go. And after we receive the key, we can close the connection because we don't need the socket connection anymore. And we'll encrypt this with the key. Perfect. And after this is done, we just exit. Great. So if we try this out now, by the way, our test, let's look at the splash. I don't know how this was configured. Oh, the monitor payment thing. We don't want this right now to do anything. Actually, we still want this to do something. So let's do 10 in here. And let's also change this so that it's not topmost and it's not full screen. And we can quit from it. Just for testing purposes, we're going to change this so that we can see what's actually happening. So right now, let's put server client. Oops, something is wrong. Oh, I didn't pass the address into here. So address, well, BTC address. There we go. That server client. Oh, damn, you can't see it. Oh, it's here. So this would be full screen and it's not paid. So now look at it. If you go into task, this is encrypted, right? You can't understand a single thing that's in here. Now, 20 seconds passed, the files are being recovered, but they're actually not. My bad. They're actually not being recovered. This is my bad. Oops, I bricked it because I forgot to handle actual decryption in here. Okay, so let's handle decryption in here. How would we handle decryption in here? So what we can do is we can make a particular check. So let's okay. I'm thinking what the best way would be, because I could add, for example, an address part in here. And now when this calls the monitor payment, the args would include address. So now it has access to the Bitcoin address as well. And what it can do is it can query our server for whether or not that particular address has received the money or not. And if it has received the money, then it can receive the key and decrypt it, right? Perfect. So let's actually do that. Not with actual Bitcoin verification just yet, but just building the building blocks. So let's make a little tiny API. We might do this like HTTP later on, but let's build another kind of like a little API in here. So def payment checker, whatever. Now we need to start this out in here. So let's so we load the keychain, blah blah. Okay, this actually can't happen like this, now that I'm thinking about it. The server needs to also send a Bitcoin. So as the server sends the key, so where's the client? So here the client actually receives, so it sends the host name and it receives the key. Now, we can handle this later on, but the client also needs to receive the Bitcoin. That would be the best way to handle this. So a BTC address will be equal to s.receive. And now here's where our headers come into play as well. Because we can have the exact same thing in here. Let's just have the exact same thing server. And don't worry, we're going to clean this up a bit later on, especially when we learn about object-oriented programming. It's going to be like really neatly packed. So right here, we're just going to get a socket. This is the exact same thing. It doesn't need anything to work with really. And after we receive, so before we receive the key, we're going to receive the Bitcoin. So what we're going to do is we're going to have our header equals to s.receive 16 in this case. And actually, let's just have our message size so that, you know, int this code. And then our BTC address is going to be equal to s.receive message size. Okay, great. And then our key is going to be the next thing. And there we go. And then we have our BTC address that is going to go into here. So now we have to make up an address to send this. So we're sending the key. Before we send the key, we need to send the address. So let's just create a Bitcoin address. So after we make the key, before we send the key, we're just going to make random BTC ADR matter. And now we're going to do a send message BTC ADR with socket being connection. Right, so now it's going to send, it's going to receive, perfect, everything is working. But of course, we still need to handle the decryption. So let's go back here to Splash. And, oh, also, I almost forgot. So, oh, our F key, okay, let's reorder this. We don't need our F key, this is not doing anything here. Now, we added the key to our keychain, but we need to add the Bitcoin address as well. So it's associated with it. So let's go keychain. Actually, now that I think about it, we should probably associate specific Bitcoin addresses as the user instead of user ID. We'll do that at some point. But let's say BTC ADDR equals BTC ADDR. Okay. And yeah, I think that's all. So let's execute this without the splash and without encrypting it so that we see that everything is working, kind of. There we go. So the BTC is this. Everything seems fine. No errors. Great. So now let's include this. And now the splash, we also need, so from here, import crypto. And for the splash to work, we need to send a request. So let's import socket as well. And here we're going to do s equals socket dot socket dot inet socket dot straight socket dot connect. Now is where we would have our host and our address. This will change when we make a different kind of connection for our actual check. But for now, let's just this 8081 because our server will be in 8081. What server, you ask? Well, our payment checker. So let's start our payment checker before we start accepting connections. So our payment thread will be, so remember when we talked about threading? So let's import threading. It's going to be threading.thread. Our target is, of course, going to be our payment checker. And the arguments that we set to it, do we need to set any arguments right now? We don't actually. Great. So payment thread is going to be daemon, and we're going to start. Great. So now this is started, but we still haven't added any logic to it. So let's make our s equal socket.socket. So it's the same thing. We can just actually copy it from, so we don't have to retype everything. And so let's bind into 8081 and this. Oh, nope. Awesome. We're just listening for one connection. We don't need more right now. And connection and our and the address will of course be s.accept. And now is where we're gonna start doing things. So first what we need to do is receive our address. So we're going to do a while true. Actually, not while true, because let's just say our header or our message size is going to be equal to, actually no, our header is going to be equal to connection.receive 16 bytes. And now while header, so what do we do with this header? So our message size equals int header dot decode, and now we're going to have our BTC ADDR equal connection.receive the size. So we have our Bitcoin address now. Then we're going to perform some kind of check. And this is where what you do, check stuff. Oh, thank you so much. Dio, oh my God, how do I pronounce that? Dio, can I just call you Dio? Thank you so much for following. Thank you so much for rating this channel with 3 viewers. Thank you so much. Just Dio, awesome. And thank you so much for the follow, guys. Carlos Dejmil. Okay. Thank you so much for follow. I was trying to pronounce your names. It's so difficult to pronounce names. And oh God. KXLZSS. Thank you for the follow. Really appreciate it. Killed Boy. Thank you for the follow. Really appreciate it. Anyway, if you don't mind, I will talk to you guys in just a second. I want to finish the logic here so people don't lose the train of thought. So the address will be what we received given the size that we take from the header. Awesome. Now to do is an actual check. We're not going to perform the actual check right now because, you know, we're going to do that in the later stage. Now we're just showing how that would be done in every other way except for the actual check itself. And after we receive this, we're going to send something. We're making a server or a malware. So right now, this is part of a programming fundamentals course that I'm doing. You can check it out in whitehathacking.tech. You scroll down to the description, there will be the website there. You can check out our Discord server as well. We are a community focused on teaching information security and hacking. And right now we're teaching Python, and we're working on our first project. Our first project is creating a ransomware, which is a piece of malware. And for that, we are creating a server to check for payments and to communicate with the client, which will be encrypting all of the files in each computer. So now all we have to do is send something. So we can either send a 1 or send a 0 or whatever. Actually, wait. So we check if it's correct or not, and then we just send the key back. So what we're gonna do is we send okay, it's easier if I just do it. So let's say check equals true, just for now. If check, so if the check was correctly performed, or yeah, or we can just have a function def check. It doesn't matter. We're just, yeah, I know it, but I have a doubt. Okay, sure. Just type it in. I'll answer in just a second as soon as I finish this idea. So if the check is true, so if the person is paid, what we're going to do is we're going to connection.send, and we're going to send the key, right? And what is the key? We don't have a key yet. So we're going to check if, so for now we're going to check. So for user in keychain, I guess, get our keychain. Wait, is the keychain a global thing? It is, so I don't need to do this for now. So for user in keychain, keychain is a global thing, is it not? Or is keychain? Oh, it's here. Well, it is, but I'm just gonna add it here because we're gonna want to actually change this in. Let's just put the keychain there, and we'll include our keychain. Might not make a lot of sense right now, but it will later when we change this code slightly. But anyway, so we have a keychain, and in this keychain object, so for user in keychain, if user BTC address, what did we call this? BTC ADDR, yeah, okay. So BTC ADDR equals our BTC ADDR. And we're going to do this in a better way, don't worry. So if they check, what we're going to do is we're going to have our key equal to, or just our connection dot send user. Wait, this is wrong. Keychain user BTC address. We're going to send our keychain, our keychain user key. Awesome. And we're not just going to send, we're going to send, do we have it? We do. We're going to do a send message. We're going to do a send message of our key with our connection. Do this here. I'm an idiot. I could have done this in a better way. With our connection. Awesome. Otherwise, and I guess we can actually return from it now. I mean, we can, but otherwise, what's going to happen is we're going to send message false, whatever, doesn't matter for now. Here. So in our splash, when we connect to this, so the first thing we're going to receive, so what is happening? So we're going to receive a header. So we have to do the same thing we did here for the send message and padding. So let's do it here, I guess. Okay. Wait, what did I just do? Did I just do it? Oh, never mind. All is good. So after we connect, what we want to do is we want to send message, and we're sending our address holy crap, address into this connection. And what it's going to do is it's going to perform its check, and then if it's and then we're going to receive something. So we're going to put header equals s.receive 16, and then while header sure, and then while header we need to perform the, oh god, we need to get the response. So what is the response? The response is either false or it's the thing. So it's only one thing, is it not, that we're sending? Yeah, it's only one thing we're sending, so we don't actually need to do this. We can just do, so message size equals s.receive int this.decode, and then our response, I guess, is going to be equal to s.receive message size. And then if response equals false, then print, well, not print, but I guess we can print for logging. Not paid yet. Else, crypto dot decrypt directory test, and with the key, which will be our response. Now, how are we sending this key? We're sending a base 64, so let's import base 64 and response. So let's just say key equals base 64 dot base 64 decode response, and now put the key in here. And at the same time, and then we're going to do this, right? Well, we should do this first, in fact, then here, and then let's make a time.sleep of 3 seconds, and let's make a time.sleep of, say, 20 seconds for now, and this should work. Okay, let me look at what you guys have said. If the computer is encrypted, then how do people need the rescue? Oh, okay. So the idea is the computer is encrypted using a key. So there's an algorithm that encrypts it. We created an algorithm a couple of videos ago. Really simple. It's not secure, but we created an algorithm that just replaces characters with a different character based on a key, and all other encryption algorithms are going to have at least a key that will be used to encrypt, and you'll also have a key, it could be the same or not, that will be used to decrypt. So if you can encrypt it, you can also decrypt it if you have the same key. The reason we have the server is because the server is going to actually save all the keys that were used for every computer. So the server can also check if the payment was received. And if the payment was received, the server then sends the computer the key so that it can be decoded. It can be decrypted. Is that clear? So let's, while we listen for the response, let's try to see if this is actually working. There we go. By the way, this was the screen that appeared. Now notice everything is actually encrypted in here. We can't see anything. Now let's see what other things are being printed. Well, nothing else now. We should wait around 20 seconds, I believe, for, yes, but the payment is made with Bitcoins, right? Yes. We're going to see how to check if the payment was made as well. It's really easy. All you have to do is query the blockchain for the particular address, and then you can okay, and then you can check for the balance in the transactions. And if you generate a different address for each client, then it's really simple, because all you have to do is check the balance and check its transactions, and you should have the exact amount that you're asking for. For some reason, this is not doing things, which leads me to believe that I have done something wrong. Well, obviously I have done something wrong, but what did I do? Let's check out what our things are saying. Oh. Wait, what? Oh, did we not start the server? Am I an idiot? Did we not start the payment checker? But like the people that were infected with the malware have to make like a bank transaction. If not, how do they pay? Oh, so let's say you have a Bitcoin wallet, right, that has a particular address. All you have to do then is sign up. If you were infected, you have to sign up to Bitcoin wallet service or something. You have to get yourself your own Bitcoin wallet. It's really easy, and we're gonna see how to do that in a second, like in the later video. And then all you have to do is go into one of those websites to trade, let's say, PayPal money into Bitcoin. And yeah, and that's basically how you do that, or you just pay it with your. There are many different ways to pay it, but essentially you transfer it to a Bitcoin wallet, and then you can check your own balance to check if the payment was made. Awesome. Also, I'm doing something wrong for some reason because the payment checker is not getting oh, wait. Payment checker, is this getting started? I feel like this is not it is getting started. Is it not? Oh God. No. Is this not getting started? It is. The hell? Okay, wait. How is this connection being refused? What am I not doing? It's a really stupid mistake, but okay. Okay. No connection. Yeah, I get that, but so in monitor payment. Okay, so in monitor payment, this was not successful. That's the only reason would be if this wasn't started in. Which should, right? Oh, wait. Let me just do a really simple check because I feel like I'm okay. It is being started, so this is being started, and oh God, oh God, I'm an idiot. Okay, yes, okay, fine. So, okay, yeah. So this is not supposed to be here at all. It was an artifact. Yo, what's up, Tropic? How are you doing? Yeah, so yeah, it turns out I'm an idiot and that was just proven live. Okay, let's try this again. It happens, like you, especially when you're doing stuff live. Oops, ransom. Okay, so let's try this again. So server. Well, now this doesn't make sense anymore, but let's, our test is gonna have a secret.txt and hello world. This is a secret password. Okay, so we can see if stuff is being encrypted or not. So let's start the server is good. Now this would appear in full screen, but I've disabled that so that we can see it happening. Now notice that this now became totally not able, you know, it became encrypted, right? Obviously. Now we're waiting for it to be decrypted. It's going to be 20 seconds, and there's another problem because that actually still occurred. Oh, because this is actually a different problem because, oh, I just realized something. Ransomware, nice. Yeah. Wait. Oh God. I feel like I'm really tired to spot this mistake. It should be a really, really simple thing. I'm pretty sure this is like such a stupid thing at this particular point. But I don't see it right now. Right. Yeah. Wait. Let me take this out so I can. Does anybody see some really stupid mistake that I made? Oh, this is not going to work because. Yeah, exactly. So why? Oh shit. Did I do something? Oh shit. Oh, okay, I get it. Okay, fair enough. So, oops. And so this socket, oh, you know what? Let me just add, so let me add a different name to here so that we can, so we can differentiate better when we're doing this. And oh, so, when I click on it, this should be more visible as well. And so the problem, oh, it's on the other, it's on the, it's on the other screen. That's a problem. Um, wait, I'm having a lot of windows open. Hey, also add in a media player which wants the ransom. Yeah, that could be something that would be added as well. That would be nice to add. Um, I think the problem is because I um I'm maybe making. I'm not making it. I'm not. Oh God, I don't get this. This is horrible. Let's see if it's a problem with my thingy. It's not. Okay, that makes sense. I don't actually get it. So let's try to debug this a bit more because this is part of programming as well. You know what? Let's just recode this. It's actually way easier to just recode the entire thing. So let's recode the entire thing. And let's make this payment socket. So socket.ifinet, socket.stream. And now let's also make a host and a port, of course. Port equals to 1 and port, let's say 4444. Now let's do payment s dot bind into port, of course. We have to also make it listen into it, right? So let's just do a listen and our connection going to be payment as accept. Let's just do this and print it for now. We still have the other thing connecting to it, do we not? I hope we have the other thing connecting to it, because if we don't, then I have to look again. I don't think I changed it. It's actually hard to like do stuff while I need to always change things from different windows. Oops, I didn't mean to exit. We don't use this anyway. Okay. So let's execute our server, execute our client, and see if our client connects. It does not connect. So this is not actually. Oh, this is the wrong port as well. So let's actually do something else here. So let's have our well, this I don't actually need to change. Let me also have a host port so that we can easily spot any mistakes in what we write in here and change it easily so we don't have to keep looking into the code. There we go. And let's do an s.send I and go. No, the whole thing doesn't actually have to happen. Try this again. And keeps blocking that. This should actually work now. Well, in theory. So let's figure out why it's not working. Oops. There's, oh. Okay. Huh. Well, I'll have to get back to you on this one, I guess. Because I really don't see why this is not working. Because the server, because the server is waiting for that connection. Is it? Let's make a little test here. So this is not what I wanted to do at all. So let's make our this. Let's import socket. Let's make this happen. Doing it line by line so we can easily spot anything wrong with it right now. Okay. Now we're going to wait for this to accept. And now we're going to open another one. So port socket, we just have the same kind of socket. So s equals this, doesn't really matter. Let's just connect into this. Oops, just connect to this. Oops, people. Okay, so this worked. Oh. Very curious, is it not? Oh well. Oh God, am I? Oh God, did I do something really stupid? Where is the thingy? here. Oh God, I think I figured it. Okay, we're gonna do this in a different way. So our payment checker will be slightly changed for now, I believe. Because even if we do this, right, by the way, so if we cancel this out, this should be control C, right? And that, oh, oops, because yeah, I'm using it on here. My bad here. We don't need this anymore. And we don't need this anymore. Because the problem is actually in a different place than I thought originally at all. Oh God, why is this not working? Because here, there we go. Oh, you don't see this? Yeah. Okay. Okay. I think so. Oh, actually, no, that makes no sense. Okay, you know what? I don't actually know. I have to look into this after the stream because it will take a long time to stay here and debug this whole thing. But I'll get back to you on the next video. For now, let's tweak this a bit so that we have something to actually do. So when we're monitoring the payment, what we're going to be doing is exactly the same thing, I guess. But we're going to receive stuff, obviously. And we need to receive the key, of course. For now, let's actually just send the key along this client. So I'm just going to send the key as well on the display hacked. And the display hacked in Splash will, is it? Here, it's going to also receive a key. And we're also going to send a key into here. And this is also going to receive a key. And now what we're going to do is we're going to sleep for, say, 15 seconds. And we're going to decrypt the directory with the key. And that's what we're going to be doing. We're going to do this, of course, first. And then we're going to do, actually, no, we're going to do first and that. And yeah, and this should be it. And afterwards, we need to exit. So from here, we do a main.destroy, I guess. There we go. And this should work. It doesn't have the server thingy. I honestly don't know what's wrong right now, and I've been trying to figure that out. But I don't want to take a lot of time because, you know. But I'll get back to you on the next stream for sure as I debug this off stream. But let's do this right now so that we at least know that the transfer of keys initially works. And stuff, oops, and stuff can be decrypted. So let's run our server, let's run our client, and boom, this appears. It hasn't been paid. Our thing has been encrypted. Our thing was encrypted before, by the way. Sorry, let me exit this and change this to txt. and just have super secret passwords. Okay, it doesn't matter. Now we're going to go for our server, our client. This appears. Awesome. And now it's encrypted, by the way, so you can't see anything. This has been deleted, so it's encrypted. We wait just for a couple seconds. 10 or 15, there we go. Now it's being decrypted, and you notice this became text.txt as well. Super secret passwords, perfect. And now it's gone. There we go. And this is how it works. Now, it is basically all parts of functionality are working except for the payment check and the receiving of the key. We'll do this next stream because I'm actually not sure what went wrong there. But I'll check it out and definitely tell you next time. Are there any questions? So this is what I wanted to show you today, but I welcome any questions of any kind. Doesn't really have to be necessarily on topic, but yeah, since we finished what we wanted to do for today. Let me make one. I swear, if it's using a different interface. While we wait for some questions, I'm just gonna. No, because we connect to here, right? So it's not really. It can't be, but could be. So I'm gonna try it out anyway. We're gonna do it. Stop. Hi. Nope, still refusing it. It's something else. Oh shit. Oh my god. Oh my. Okay. Oops. Did I do it? No, but that was really stupid of me. Wait, can I roll it back to where it was? Actually matter. No, that's not what I wanted to do actually. I wanted to roll it back to a previous. Oh, oops. Maybe it was not that. Oh no, it was not that, I guess. Never mind. Okay, if there are no questions, I guess we will finish in around 2-3 minutes. I just made a couple changes. I'm still desperately trying to figure it out, but I don't think it's a simple. I think it's a simple thing, but it's not a simple thing that will be solved just by trying some stuff at a particular point. Because I think something wrong that I did in coding. Thank you so much for following. Soft PT. Oh, I'm sorry. Was I too far away from the mic? I'm sorry. Um, so I was asking if you guys had any questions since this is basically what I wanted to show you. And I'm sorry for the whole the payment checker server not socket connections not really working. I will definitely get back on you next time. Port 444 on firewall. No, I just tried that. I tried to let it through right now, and it's not that. So I don't know. Don't actually know. I have to check it out later on. Maybe there are some firewall issues that I didn't really. Maybe the firewall configuration was typoed or something, but it is weird that it's not working. I will definitely check it out next stream. I'll let you guys know if there are any questions about anything at all. Yeah, I did. I just turned the firewall off. It didn't matter. Um, you know what? I bet with you right now, if I did this, copy this, let's comment this out, paste it here, and run it, that this will work. I bet with you anything that this will work right now. So let's execute the server. Let's execute the client. Oh, it doesn't. Wow. Oh, I was wrong. Yeah, so there's definitely something going on with here. This, and I'm not quite sure what it is yet. But we'll check it off. We'll check it out later on. Don't worry. Anyhow, I hope you liked the portion of the stream that was not completely botched. Now you owe me anything. Fair enough. Well, you didn't accept the bet necessarily, so but yeah. Um I don't know, it's definitely weird. Not gonna lie. There's just something I'm missing. I'm not sure what it is. Like, I mean, I've done thousands of these things. Like, I never actually had this be an issue before. I don't really know. It's definitely something I'm missing that I don't see at this particular. Oh well. But thank you guys for stopping by. Um, yeah, that wouldn't make a difference because it's a local connection. It would have made a difference if we were connecting from the outside. But I mean, it's not really about this. No port works, right? The 8080 port works. This doesn't. I don't know. Something more obscure, maybe. Maybe at some point, one of our people on Discord will be watching and they'll DM me saying I'm an idiot and telling me why it's not working. Oh well. I'll debug this definitely as soon as the stream ends. But yeah, if there are no more questions, I will be ending this presently. And I hope you enjoyed it. At least, you know, the portion that was not completely botched. So basically, to recap what we did today, we built the first portion of the server, which includes obviously listening for connections, performing an auth exchange, so exchanging keys with the client. So now the client knows what key to use, and also storing it in a keychain. And that was basically it. The next step will be to connect to make our thread that will continuously query the server for whether or not the particular address is is paid for. And I mean, we don't need a separate socket for that, honestly. We could do it on the same one. And we might actually end up doing that at some. But now I really want to have a second socket because I want to figure this out. But we can do it on the same one using threads to spawn up every time that a connection is accepted. And having the exact same handling of it. So we have a multi-threaded thing going on. So we can have multiple clients as well, and just have like a little check. So it's at first. So in our header, we could include something else other than the size. We could include like a little bit in the beginning. If it's 1 or 0. If it's 1, it's to check. If it's 0, it's to get a key. Something like that. We can also do that. That might actually be a better way to go about it. But yeah. So thanks for watching, guys. Thanks for stopping by. Thank you for the raid. It was really amazing. And see you guys tomorrow. And of course,